Hello, welcome to the Bakwas channel for self-paced tutorials on robotics. This presentation demonstrates a line item from the Quality Assurance Checklist for a high school robotics team. Robot motors can be connected to prime mover wheels in many different ways. The motor can be connected directly to the wheel, but naturally this connection is inadvisable for loads that are not light. The motor can be connected to the wheels through chains, pulleys, or belts. The motor can be connected through gears, which themselves have many variations. It is possible that for some chosen method that connects the motor to the wheel, the direction of rotation of the wheel is incorrect. Fortunately, a basic reversal of the rotation can be accomplished very easily in the initialization section of the program that drives the motor. The primary objective of this op mode is to provide a very simple way to test the rotations of the motors. If the motors do not rotate in the expected directions, then the robot will be unable to perform any task using the motors. It is important to ensure that the motors are rotating in the right direction before any field test is performed with the robot. It is better to validate this requirement at the earliest opportunity before proceeding to more extensive programming tasks. The changes will be specific to each robot, since for the same mechanical geometry, a robot can have vertically, axially, or longitudinally mounts for the drivetrain motors. If two or more motors are mounted in identical configuration, then for basic linear travel movement, it is highly probable that the rotation of one of the motors will have to be reversed. This reversal is performed in the initialization section of the op mode. After all changes have been implemented, it is prudent to test the rotation of each wheel separately to isolate any issue. This slide is a very simple example to illustrate the need for reversal of rotation of one of the motors. The image on the left is that of a simple motor from robotics that is used in an elementary robot called Minibot, whose drivetrain is shown in the image on the right. The arrow on the motor specifies the direction of rotation for the motor. Without any changes, it should be apparent that the rotations of both motors without any changes in code will rotate in opposite directions. In other words, the robot will spin in place and will be unable to perform linear travel. This is a very common first time observation for rookie teams if the default settings are not changed. For this reason, one of the motors must rotate in the opposite direction to its default setting. This is accomplished by invoking a simple method called to reverse the rotation in the initialization section of the run method of the op mode. Naturally, it's up to the user to select which motor's rotation to reverse in code based on which movement constitutes forward or backward linear travel. Set the rotation direction of a motor with the corresponding command. The default setting is forward. If required, you will have to set it to reverse. Assign a gamepad button to each motor. When you press a button, the corresponding motor will spin as long as the button is pressed. You may wish to lower the rotation speed to view the spin direction closely. Press each assigned button and confirm that the wheels are spinning correctly. If not, then the change direction setting for the motor or motors where the spin has to be reversed. Run the updated op mode and validate. The gamepad buttons offer a quick way to test the rotation of the wheels. When a button is pressed, only the corresponding wheel should rotate for forward movement. If this is not the case, then the direction of rotation for the corresponding motor should be flipped in the op mode. It may be necessary to lower speed of the motor for easier visibility of the rotation owing to geometric patterns on the corresponding wheel. All wheels are stationary when no button is pressed. If the corresponding wheel does not rotate when a button is pressed, then check the mechanical structure and the electrical connectivity. Often the motor is mounted too tight for the axle to rotate freely. Launch the op mode from the teleops drop-down list. Touch Init, touch Play. Cycle through the gamepad buttons. Observe the rotation of the corresponding wheel when a gamepad button is pressed. Record your observations in the checklist log. If the wheels rotate correctly, Then transfer the robot to the programming team for their development tasks. Inspect all drivetrain components for damage. Check that all components are present in the documented positions. Verify that all connections are secure. Test the robot to ensure that it functions properly. Clean and lubricate the wheels as needed. Document the inspection and testing results. This checklist covers the basic steps that should be taken to ensure the quality of a robot assembly. The specific steps may vary depending on the type of robot being assembled. However, the general principles of quality assurance should remain the same. Here are some additional tips for creating a quality assurance checklist for robot assembly. Be specific. The checklist should be specific enough to ensure that all important steps are covered. Be comprehensive. The checklist should cover all of the steps involved in the assembly process, from inspection to testing. Be easy to follow. The checklist should be easy to understand and follow. Be updated as needed. The checklist should be updated as new components or procedures are introduced. Some of the benefits of using a checklist for robot assembly are increased quality. A checklist can help to ensure that all robots are assembled correctly and that they meet all quality standards. Reduced defects. A checklist can help to identify and correct defects early in the assembly process, which can help to reduce the number of defective robots that are produced. Improved efficiency. A checklist can help to streamline the assembly process and improve efficiency. Increased driver satisfaction. Drivers or teleoperators are more likely to be satisfied with a robot that has been assembled using a checklist. Launch Android Studio and drill down under Team Code Java utility to locate the Mecanum wheel spin op mode. This op mode tests the spin direction for each wheel. The names of each motor, as specified in the configuration file, are declared here as string variables that are then used to map the hardware for the motors. And along that same loop, the brake and run without encoder settings are applied to the motors. The spin direction by default is shown here initially, and two of them have already been flipped from the default. Each button will spin only one wheel: X square, A cross, Y triangle, and B circle. Run the op mode from the teleop menu. Make sure the robot is connected to the right network and that there is a gamepad connected. Oops, we forgot to connect the gamepad. Let's go ahead and do that right away. And the gamepad icon will show up here instantly after the gamepad is connected as now. Make sure the battery levels are correct and that we're using the right configuration file. On the teleop drop-down list, scroll down and select Mecanum wheel spin. Touch the init button and then touch the play button. The prompts will be displayed shortly telling you which button for which wheel. In our example in here, we have for the left front, we're going to use the X square button to spin the wheel. We're going to use the A cross button for the left back wheel. We're going to use the Y triangle button for the right front wheel. We're going to use the B circle button for the right back wheel. A pro forma checklist is shown on this slide for the team's third robot called Asima. Of course, this checklist is limited to the operation of the wheels. It is part of a larger checklist which is impractical to illustrate here for the limited purposes of this tutorial. The tests were performed on the four wheels individually. The current state of the motor spin direction was known prior to the start of the test. The operator pressed the corresponding gamepad button and observed the spin direction. The wheel did not spin in the required direction for the two wheels on the left side of the Mecanum drivetrain. After entering the recommended states for the motors, the checklist was returned to the team to make changes. The direction of the motors were changed where necessary to ensure that pressing a gamepad button resulted in a forward spin for the wheel. Each wheel spun only when the corresponding gamepad was pressed. That's all, folks. Please provide feedback in any which way you can. This presentation was prepared with assistance as noted on the slide. My apologies if I have unintentionally omitted anyone or any resource. A very big thank you to y'all. Come back to the channel soon.